You're welcome to today's video. Now we'll be looking at an experiment involving a glass block. Here's a typical experiment involving a glass block. So you might be given a question that looks like this. You have seen the diagram. That's the diagram for the question. Now the instruction reads, measure and record the thickness of the glass block provided. That means we are provided with a glass block, and the thickness of the glass block is that dimension B. Trace the outline ABCD of the glass block on the sheet of paper as shown. Remove the block and draw a normal at N. Draw an incident ray such that the angle of incidence I is equal to 25 degrees. Fix two pins at points P and Q on the incident ray. Replace the glass block and fix two other pins at points R and Y such that the pins appear to be in a straight line with the images of the pins at P and Q when viewed from the side DC of the glass block. Remove the block and join the pins at R and Y, producing the line to meet DC at X. Join NX and measure its length L. Evaluate L raised to the power of -2 and sine square I. Repeat the experiment for the various angles of incident I to be 35 degrees, 45 degrees, 55 degrees, and 65 degrees respectively. In each case, determine the corresponding values of L, L to the power of -2, and sine square I. Tabulate your readings. Plot the graph of L raised to the power of -2 on the vertical axis and sine square I on the horizontal axis, starting both axes from the origin. Determine the slope of the graph and the intercept I on the vertical axis. And lastly, evaluate the expression K is equal to the intercept I all over the slope S, all to the power of half. That's 1/2. So this is all about the question. So we are going to proceed to how we are to tackle it. But what I want to reassure you is that you don't need to touch any apparatus at all. All you need is just a little background knowledge concerning this topic in physics. And with that knowledge, you are good to go. Let's continue. Let's move ahead. Now we have traced our glass block and we have drawn the diagram as shown. The next step is to, like the question told us, we have to measure the thickness of our glass block. And assuming I have done my measurement, I have done mine, and the thickness of my glass block is 6.5 centimeters. The thickness is the dimension B, as you can see in the diagram, and it is 6.5 centimeters. Like I said earlier, in this practical, there is no need of performing the first round or the first set. All that we need is right at our fingertips. So let's proceed. And to do that, we have to remember one important fact, and that is that the practical hinges on the refractive index of the glass block, because this practical is just talking about the refractive index. And if we know that, what else are we looking for? So the refractive index of a glass block N is 1.5. That is the value. How did we know that? We got it from theoretical knowledge. Okay? Now we trace our glass block. For the first experiment, we indicate the angle of incident as 25 degrees as shown in the diagram, and this is the thickness of our glass block. Okay, we represent everything here drawn accurately. But before I proceed, the only thing we can draw accurately here is the 25 degrees, which we can measure with the help of our protractor. But we don't really know the value of angle R. We don't know the value of the angle R, which is the angle of refraction. We don't know the value. So we need to get that value. If we get it, the rest is a piece of cake. Line RY is parallel to line PQ. Okay, so that is not a problem. If we can, the issue here is how we can get the accurate angle of refraction so that we can draw our value, so that we can draw the length of our L, the length of that L there you are seeing. That is the issue. But it's not really an issue anyway, because I'm going to show you that it's not a problem. So we recall that the formula for refractive index N is equal to sine of the angle of incidence all over the sine of the angle of refraction. So we now say when the angle of incidence is 25 degrees, we now say 1.5, which is the refractive index of a glass block, all over sine 25 is equal to, 1.5 is equal to sine 25, which is at the angle of incidence, all over sine R, which we don't know. Okay, then simplifying everything, as you can see, we observe, or we got that the angle of refraction here is 16.36 degrees. Then I produced this line from the normal end. I produced a right angle triangle. Okay, from that right angle triangle, I have imputed the value of my 16.36. I can see that the length, the thickness of our glass block is this other side. You can see here, I just produced that triangle. So this 6.5 centimeter is also the thickness of our glass block, and the other one, the hypotenuse, is the length L we are looking for. So with our knowledge of Socatoire, we deduce that L is equal to 6.5 divided by cosine of the angle 16.36, and we got the value of our L to be 6.77 centimeters. Okay, and once we've gotten that, we indicate it in our table of values, and this is our table of values. Remember, we have to record the value of different values of the angle of incidence. This is the sine square of the angle of incidence. This is the L, which we've gotten 6.77. This is the square of the L, and this is the inverse of the square of the L, which we have here. So we have filled the first column, the first row. We have filled the first row of our table of values. So the same procedure goes on and on and on. So let's move to the next phase. Now, the next phase, we still have the same glass block traced. The difference here now is that the angle of incidence has increased from 25 to 35. Okay, so what we are going to do here is also to find our angle of refraction. So which we, like I said, we'll continue with the trend to do that. So when the angle of incidence is 35 degrees, what happens? We still follow the same trend. 1.5, which is the refractive index of the glass block, is equal to sine 35 all over sine R, which is the angle of refraction. And simplifying everything, we find out that the angle of refraction itself, R, is now 22.48 degrees. 22.48 degrees. So we also input it in that right angle triangle you are seeing there, and from the same principle we get the new value of our L, which we have as 7.03 centimeters. And once we've gotten that, we input it in our table of values and also evaluate the other parameters. We'll solve for the value of sine square I, get the value of the square of L and the inverse of the square of L. As you can see, the number of decimal places in my table of value is uniform. It's very important, very, very important. Don't forget that. So the same procedure goes on for when the angle of incidence is 45 degrees. So we also continue. When the angle of incidence is 45 degrees, so what then happens? As usual, okay, when the angle of incidence is 45 degrees, so we now see that 1.5, which is the refractive index, is equal to sine 45 all over sine r, and simplifying or to get the value of our r, we will find out that r itself here now is 28.13 degrees. Then also inputting it in that right angle triangle and evaluating for L now gives us 7.37 centimeters. Okay, and we'll now input it in our table of values and find or evaluate the other parameters. So here now at 45 degrees, our L is 7.37, L square is 54.32, and inverse of L square is 0.018. Okay, so this is it. As you can see, do you see how the table of values is, how we are getting our values so easily and filling our table of values? So this is just what the practical is all about. I know by now you can be able to find the other values when the angle of incidence is 55 and 65 degrees. So it still follows the same principle. The same principle is applied repeatedly. Nothing changes here. Once you've understood it, you've understood it. Okay, so let's continue again. So also when I is that angle of incidence is 55 degrees, so following the normal procedure, and we'll evaluate and find our angle of refraction to be 33.1 degrees, yes, 33.1 degrees. Sorry, that was a mistake. Find out the angle of refraction here is 33.1 degrees. Okay, so we also impute it in our right angle triangle we carved out from the diagram. Once we've done that, evaluating it as we do before. Okay, L equal to 6.5 all over the cosine of 33.1. we'll get the value of our L to be 7.67 centimeters, and we fill it up in our table of values and also evaluate the other parameters, as you can see. Then lastly, we have when the angle of incidence is 65 degrees, the same procedure happens again here. You can see when the angle of incidence is 65 degrees, 1.5 is equal to sine of the angle of incidence all over sine of the angle of refraction, and simplifying, breaking it down, we get the value of the angle of our refraction to be 37.17 degrees, and imputing it in the right angle triangle carved out from the diagram there and evaluating for L, we found out that L, which is the length of the hypotenuse, is equal to 8.16 centimeters. And once we've done that, wow, we now impute it in our table of values and evaluate for the other parameters. We evaluate for the sine square I, sine square of the angle of incidence. We evaluate for L square and we evaluate for the inverse of L square. So once we've done those things, then we are good to go. We are heading straight to the graph plotting. We've gotten our table of values. Now notice that here we are plotting the graph of L raised to the power of -2 on the vertical axis and sine square I on the horizontal axis. So this is our table of values. Everything is down there and ready. Okay, and remember, for us to plot our graphs, you must choose your scale appropriately. Then you must write the title of your graph. Okay, make sure that the two axes of your graphs contains the symbol and their units, and we go straight to the graph plotting. Okay, and when we do that, then this is how our graph will look like. It's still a straight line graph. Still a straight line graph. Okay, straight line graph. As you can see, very nice. So your graph should look like this. It is a negative slope graph. The graph is a negative slope because it's falling, it's not rising. Okay, so for us to find the slope of the graph, we also take 2 points. So slope is usually calculated from change in the vertical axis, change in the values of the vertical axis, all over corresponding change in the value of our horizontal axis. So, and we're taking 2 points from the vertical axis, which is 0.02 minus 0.018 all over 0.33 minus 0.5. So when we do that, we find out that our slope has a negative value, which is minus 0.012 centimeters square. And then that is it. And they told us to evaluate something. And also we note that the intercept, that's intercept means where the graph as the line cuts the axis. It could be the vertical axis or the horizontal axis, depending on the intercept we are looking for. Intercept is just a point where our graph cuts the both axes, either the x-axis or the y-axis. That's either the vertical axis or the horizontal axis. So here we are looking at the intercept on the vertical axis, and you can see the point where the graph cuts our vertical axis is at the point 0.022. So once we've gotten that, remember we are trying to evaluate k, which is equal to the intercept all over the slope, then all raised to the power of half. So once we've done that, the value of k is giving us 1.4 centimeters square. You can see that value 1.4. That value 1.4 is close to the value of the refractive index of a glass block. So you can see how the value of the refractive index has helped us to perform this practical without even actually doing it. So this is very, that's why a good theoretical knowledge of what you are trying to perform, of the practical you are trying to perform, is very, vital in outsmarting this kind of questions. You are done. Now, as you can see, I did not perform any practical. The only thing I did here from the question was to measure the thickness of the glass block I was given, and after that, nothing else. I did absolutely nothing else. I didn't touch any other practical material. Okay, remember, if you have some questions, don't forget to drop your questions at the comment box, and I will attempt and answer and clarify you on some things. And I hope you find this video helpful. Try to subscribe at the end of the video. Have a wonderful day.